Let's get this started. So, all right, so today I'm going to talk about making web development awesome with visual diffing tools. So just before we get started, how many people in the audience use screenshots in some form in their ordinary workflow for their product? Okay, there's a few hands. It's actually more than I've seen before. So this is like a relatively savvy crowd in terms of screenshot testing. I think it's a relatively unknown technique, but I think it's a really great technique. And so for the people who didn't raise their hands, hopefully you guys can leave here today knowing what it is and maybe how to get started with it, whether it's appropriate for you. So a little bit about myself. I spent many years at Google, increasingly working on UI-related things over the years, which is where I started to get familiar with some of these techniques. And then about a year ago, I left and started working on open source software in a research group at Mount Sinai, particularly around visualization of genomic data. Leaving one environment after many years and going to a new environment made me a lot more interested in issues around developer workflows and testing, things that I had been kind of implicit and I hadn't thought about before, suddenly became very apparent to me. And so this talk also kind of comes out of some observations from that. All right, so today we're going to talk about what screenshot tests are and what visual diffs are. Then we're going to go through an exercise of creating screenshot tests for a tool, for a web app. We're going to talk about how you can use screenshot tests in version control and pull requests in code review to improve that. And finally, we're going to talk about some problems with screenshot testing, and I'll offer some advice about how to approach screenshot testing when it's appropriate to use. So let's start off with screenshot testing. So this is sort of the motivating example for why screenshot testing is a good idea. So let's see if I can play this video. So a couple of years ago, Brett, who's an engineer at Google, who's also a speaker here at PyCon, accidentally launched a pony to his production site. You'll see the pony if this video loads. It might not. It's on YouTube. So Brett thought he was launching a feature. There it goes. There's the pony dancing back and forth. So Brett thought he was launching this funny, cute feature with CSS3 transitions to his internal-only page, the internal-only version of his dashboard. But because of a simple mistake, it turned out he actually launched it to all of the users externally of the dashboard. And this is kind of funny. You know, it went live over the weekend because they used continuous deploy, and they didn't notice it until the next week. But you know, it's a funny example. We can watch the pony again. It's a funny example, but if you step back a little bit and think about it, it's also a terrifying example. This change, the page that it's on, is very well covered by unit tests. The change went through code review and was approved. Presumably, the code reviewer also assumed it was only going out to an internal version of the page. None of the metrics in production changed as a result of this unicorn. And yet, when you look at this page, it's obviously broken, right? There's something wrong with this page. And there's kind of if you want to get Rumsfeldian about it, right? Like there's unit tests. You can think of unit tests as checking for things that you expect might break, where it's the known unknowns. Whereas with screenshot tests, what you're really looking for are the unknown unknowns. No matter how many unit tests you write for this page, you'll never write a unit test that checks, is there an animated pony on the page? It'll just never happen. Oh, I guess we get to watch the pony one more time. So if you want to remember what screenshot tests let you find those ponies. So what do I mean by a screenshot test? To create a screenshot test, you bring up a test server, you get it into some known configuration, and then you take a screenshot. Often this is done using Phantom.js, which is a headless version of WebKit that you can run without any sort of user interface. Some people use Selenium and use real browsers like Firefox or Chrome to take the screenshot. You can do it either way. And then once you have that screenshot, you check how the pixels change over time. Changes in pixels often reflect desired changes, but sometimes they can reflect bugs as well. So you can imagine how if there were a screenshot test for the dashboard page, then the change that added the unicorn would have shown up very clearly in a screenshot test. So what do I mean when I say a visual or a perceptual diff? This is a way of helping you spot the differences between a screenshot before and a screenshot after. So let's go through a few examples of this. So this is a simple web application that we're going to use as a demonstration throughout this talk. It lets you compare the areas, the size of two different geographical features. So there's a before and an after here. Can anyone spot the difference? Yeah, there's a feedback link on the after image that's not there on the right. So this one is relatively easy to spot the difference. The difference is fairly noticeable. It's bright red. The perceptual diff is another image where you remove all the pixels that haven't changed, and you focus only on the pixels that have. So if you looked at the before and after image and couldn't spot the difference, as soon as you look at the perceptual diff, the image on the far right, it would be very clear to you that, sure enough, there's a feedback link that's been added. So let's try another example. I don't know if you guys can you guys see the lines? It's a little bit faint, unfortunately. So can anyone spot the differences here? This is actually going to be even more subtle than I expected. Yeah, so there's two changes going on here. So the big one is that there are horizontal grid lines, which you might not be able to see on this projector. There are fewer of them in the right version of the chart. But then there's also a pretty subtle difference, which is that the x-axis labels, on the left, they don't have a space in them. On the right, they do have a space in them. So you can imagine that this is a change that if you were just looking at the before and after, it would be really hard to spot that. But if you look at the perceptual diff, you see that, okay, something changed about the text in the x-axis labels. What was it? And you focus in on that part of the picture, and it's much clearer. Here's another example. The last one was maybe a hint as to what the difference is here. Can anyone spot it? Yeah, exactly. So the labels changed from Feb 10 to Feb 2010. Screenshot testing is particularly well suited to anything that involves visualizations. Visualizations are kind of a hard thing to unit test. You can write assertions like x-axis label is February 2010, but for things involving the lines themselves, it's very hard to write assertions for those that really capture what's going on. I think the visual diffs and screenshot testing kind of meet visualizations on their own terms by being inherently visual. So again, here's the perceptual diff. So you can see it's a little bit of a smudge, but you can at least see that it's the x-axis labels that are changing. So here's one final example. This one's super subtle. Can anyone spot what the difference is? Well, maybe the perceptual diff can help us. So it looks like the borders on the right and bottom have shifted by a few pixels. So the box has either gotten wider or narrower, and it looks like the text has maybe moved a little bit. So I think what's going on is that the version on the right has a little bit more padding, has maybe 1 pixel more padding than the version on the left. So if you were doing a CSS change that affected your entire site, you can very easily imagine that some sort of regression like this would creep in and you wouldn't notice without a screenshot test. All right, so now let's talk about how you would generate screenshot tests. By the way, if you want to follow along with the slides, the link is at the bottom here. It's bit.ly/PyCon 2015 visual diffs. So there are no shortage of tools for generating screenshots. This is a list that's sort of roughly in order of number of GitHub stars. So Casper.js is a wrapper around Phantom.js, the headless WebKit, that gives it a slightly nicer API for taking screenshots. Huxley is a tool that Facebook created, but it has a lot of stars, but if you go to its page, it says this project is archived, don't use it. So I guess don't use that. Wraith is a similar tool that the BBC put together for tracking changes on their website. Phantom CSS is another wrapper around Casper.js that makes it a little bit more declarative. And Depicted is the tool that Brett built to make up for launching a pony. So just because Depicted is the tool that I know best, I'm going to use that for these examples. But there are many options, and as I mentioned before, many of them use Phantom.js, but some of them also use Selenium. So if you like Selenium, you can use that too. All right, so for our demo of creating a screenshot test, I'm going to use this little app, Comparia. So just give you guys a quick demo of this. So Comparia is a tool that lets you compare the areas of different locations. So here we're comparing the United States and Australia. But one I was curious about coming here was, I'm coming from New York City. So I was curious about New York State versus Quebec. Somehow in my mind, I thought they were maybe, a similar size. Turns out they are not. So maybe a better comparison was like Texas. Turns out Quebec is also a lot bigger than Texas. So I was thinking like maybe, the United States is a better comparison. So I had no idea Quebec was this big. Like, wow. So the data for this is coming ultimately from OpenStreetMaps, mostly via natural earth data, which is a nice packaging of OpenStreetMap data. It's a simple Flask app that has a big JSON file as its data store, and it's using D3 to render the front end, so you can do nice things like drag the shapes around. The thing that motivated creating it was I moved from San Francisco to New York City, so that's another fun comparison. That would be New York State. New York City. There we go. So anyone who's made that move, this is probably a comparison that you've been interested in making, but most maps make it difficult to do. One other one I think is kind of fun is I had no idea how big Antarctica was until I started playing around with this. Turns out it's actually like really large. It's like bigger than the United States. All right, so let's create some screenshot tests. So head over to the terminal. Is this big enough for you guys to see? Maybe make it a little bigger. Can people in the back see the text on the screen? Yeah? Okay, cool. All right, so as I mentioned, this is a simple Flask app. So let's go ahead and create some screenshots. So I'm going to create a screenshots directory, and I'm going to create a configuration file for Depicted. So first up, I have to tell it how to start the server. So I'm going to create a setup step, and that's just going to, it's cut off, okay. Almost. Is that better? Yeah. Okay. Let's try to get the other side too. There we go. All right. So we need to bring up the server, so we just run run.py. Depicted needs to know when the server has successfully come up. It has to load that big JSON file first. So we need to tell it to wait for a particular URL to become available. So this is a Flask app, so it just comes up on the default Flask port, which is port 5000. So it's going to pull the server until that URL resolves. And then we need to write our tests. So let's call this one screenshot. And we'll just go to the same URL as above. And that's that. That's our screenshot configuration file. So one thing to notice is this is actually it's pretty easy to write one of these tests. It's a very black box form of testing. So as long as you can bring up your server in a test environment, writing a screenshot test is pretty simple. All right, so that's our screenshot configuration. So now we're going to tell Depicted to generate the screenshot. By the way, you can install Depicted with pip. dpxdt. It's like delta pixels over time depicted. All right, so we're going to tell depicted to update that screenshots folder. So it says that the test request succeeded, and it loaded that page, and it took a screenshot. So let's look in the screenshots directory. So now we have two files. We have the configuration file I created, and we have the screenshot. So let's check it out. All right. So there it is. It's a little bit small. It has kind of, you might not be able to see it, but it has a gray background, which is different than what the production application had. So, but we have a screenshot. So that was pretty easy. So let's fix that issue. So let's open up our configuration file again. So we're going to tell it to use a slightly larger viewport. So I think the default is something like 400 by 200, something really small. So let's make it 800 by 600. And let's add some CSS that makes it have a white background. All right. And now let's regenerate the screenshots. So it's going to bring up the server again and take the screenshots again. And now let's see if that made a difference. Sure enough, it's bigger. It has a white background. And we're good to go. So the thing to notice there is that creating the screenshot really did not take very long. That took 2 or 3 minutes. So this is not a difficult thing to add to your app if you feel like it will help you. So screenshot testing is really about tracking changes over time. So let's try making a change and see how it affects the screenshot. So what I'm going to do is I'm going to make this line that says Australia is larger than the United States. I'm going to make it a little bit bigger and see what that change looks like in the screenshot test. So let's open up the CSS file. Let's find the relevant div. So it's 25 pixels tall now. Let's make it 50 pixels. And let's make the text a little bit larger. And now, instead of running depicted update, I'm going to run depicted test. So this does the exact same thing, except instead of writing this new screenshot out to disk, it's going to compare with the existing screenshot that's on disk. So what it's saying here is that the screenshot failed because the pixels didn't match, the images didn't match pixel for pixel. In fact, almost 10% of the pixels were different. And so it's written out these three images for us to look at. And because this is OS 10, they're all in very obscure temp folders. But we can open these in preview and get a sense of what's going on. So here's our original image. Here's our new image. And here's the perceptual diff between them. So original, updated. You can see that sure enough, the text got larger. And then there's the perceptual diff, in case we were having trouble spotting what the difference was. So again, it's fairly simple to get this process going. So that worked pretty well, but this is actually not how I work with screenshot tests in practice. What I actually prefer to do is I prefer to commit the screenshots to source control. So let's go ahead and do that. So we have 2 new files in that screenshots directory. We have the screenshot and we have the screenshot configuration file. So let's just go ahead and commit that. And now, to track my change, I'm just going to run update. So once again, that's going to start up the server, capture the screenshots. And now when I run git status, there's 2 changes. There's the change I made to the CSS file, and then there's the corresponding screenshot. So you can see when you run git diff, you see this change to the CSS file, and you also see that the screenshot has changed. So I like how the change to the CSS file looks. I'm maybe less excited about how git diff renders the change to the screenshot. So what you really need is a tool that can work with images and diffs of images. So the other tool I'm going to talk about today is called webdiff. So you can install this also with pip. And I'm going to talk a little bit more about how this tool works later. So instead of running git diff, I can run git webdiff. And what this is going to do is it's going to bring up a web browser, which is too big, unfortunately. So let me try to make that the right size. So this shows the diff it shows the diff right here in the web browser. And you can see the images. So it shows the before image on the left, the after image on the right, and you can see the differences. You can also have it blink the images. And I actually find this to be by far the easiest way to look at image diffs. Your brain is really good at spotting differences between images, and not just spotting where the differences are, but interpreting the differences. So as you're looking at this, it's pretty easy to tell that the text on the top is getting larger and the shapes on the bottom are shrinking. If you think about that in terms of the raw pixels of the image, though, those are actually both really complicated changes. But your brain does a really good job of figuring out exactly what's going on. So I find that this blink mode is a really easy way to spot what changes. It's also possible to generate the perceptual diff here if you want to highlight. The colors are a little bit crazy, but you can see what's going on. So what is webdiff doing? So when you start webdiff is a Python program, and when you run it, it starts up a Flask server and then opens that window in your web browser. So I'm gonna talk a little bit more about that in a minute. So let's go ahead and make a different change. So I'm just gonna reset this. So one thing that is missing in Comparia is a logo. So let's try adding a logo. So let's find the body tag. So let's just add a logo div. When I was creating this, I wanted to learn how to do. I wanted to learn how to make a responsive design. That wasn't something I had done before with media queries, and that's another area where perceptual diffs and screenshot testing really excel. They really help you find bugs relating to to responsive designs. All right, so let's add some styling to the logo div. So let's make it position absolute. Put it in the top left. Let's give it some padding. And let's make the font large. All right, and so for this example, I'm going to use the real perceptual diff tests that I wrote for Comparia. So I'll just show you those real quick. So there's the same sort of setup step and wait for step as before. There are a lot of different viewports that I'm testing with because I wanted the responsive design to make sure that worked. And then there are quite a few different pages that it loads. So let's give that a try. So as before, it's going to start up the server, and it's just going to go through each of these tests. So this takes a little bit longer because there are more tests for it to run through. But that's something that is one drawback of screenshot tests, is they do take a little bit longer to run than unit tests. You probably don't want to use a screenshot test to check that your code sorts a list correctly. A unit test would be a lot better for that. So, all right. So all of our screenshots have changed. So let's go ahead and look at what those changes look like. So here's the place where we added the logo and the HTML. And here's the before after. So with the blink, we can see the logo. So it looks fine here. I should have made the text Comparia, not logo. I guess I wasn't thinking. But here on the mobile landscape screenshot, you can see that there's kind of a problem, right? We can highlight this with the perceptual diff. So the logo is overlapping with some of the text on this image. So clearly we need to be a little bit more sophisticated. Maybe we need to add a media query that hides the logo if you're on mobile where we don't have quite enough space to show it, or maybe we need to show it in a different place. But there's an issue with the design that was called to our attention via the perceptual diff. Here's another. This one's a little harder to see. There's a selector with United States contiguous 48 in it, and 1 pixel of the logo is peeping out from behind that drop-down list. So you might not be able to spot this as easily without that pink box highlighting it. So again, this is an issue that might have been hard to spot if you were just going through the web UI yourself, but it's quite clear when you use the screenshot test. Okay, so let's get back to this slide. So let's talk a little bit more about that webdiff program. So the way that it works, when you run it, it starts up a Flash server and then immediately connects to it in a new tab in a web browser. So this is kind of the core of the logic of webdiff. So it runs your Flask app on a random port, and then lets it start, and then 1/10 of a second later, it opens that port in a new tab using Python's web browser module. So this is actually I think a relatively obscure module. I had no idea it existed until I wanted to do this and found out it was exactly what I wanted for the task. It respects the user's preferred browser on their platform, and it knows how to open that browser for you and open pages either in new tabs or in a new window, depending on what you want to do. So it's basically perfect if you want to do this. So why would you want to architect an app this way? So diff tools are a type of app that's typically built as a native app. If you want a graphical diff tool, it will typically be built as a native app. I've had trouble finding a diff tool that I really liked in macOS 10. The 2 things I wanted were side-by-side diffs, and I wanted syntax highlighting. And I was having trouble finding those in any non-commercial diff tools for macOS 10. But I knew that there were a few JavaScript libraries for doing syntax highlighting and for rendering side-by-side diffs in the browser. So I just thought, like, why not, make this a little local web server? And it was quite easy to create a command line tool that way. I think this is a pretty interesting strategy for building things that are traditionally GUI applications. It lets you tap into the pretty rapidly evolving web development stack and use all of those nice tools. So the webdiff is built using React.js, for example, which is a quite contemporary UI framework for web development. If you're a web developer, this is also a really fun way to write web apps. If you think about it, this is the dream environment for building a web application. The web server is running locally on the same computer as the web browser. All of your connections are incredibly fast. They're incredibly reliable. You're working with a developer, presumably, so you can assume that they're not using a really old web browser. You don't have to worry about IE8. So if there's some GUI app that bothers you, I'd definitely encourage you to consider trying this strategy for building a better version. I don't know how widely used this technique is. The IPython notebook definitely does this. When you start a new IPython notebook, it spins up a web server and immediately connects to it. If there are other examples, I'm curious to hear about those. All right, so let's talk a little bit about screenshots and version control. So I suggested committing your screenshots to your Git repository every time they change. Why would you want to do that? So one reason is that having your screenshots in your repository creates this kind of living gallery of what your app is. If a new person comes to your open source project and has no idea what it is, they can just look at the screenshots in your perceptual diff tests folder, and they can see a wide variety of states that your application can get into and get a really clear sense of what it does and what it's supposed to look like. GitHub has a nice image viewer, so they can just do that on the GitHub website without even needing to check out your code. GitHub also supports showing image diffs. So screenshots work really well in code reviews and pull requests. If you get a CSS change in a pull request, usually it's really hard to know what's going on, whether it's doing the right thing, whether it has collateral damage. So including the screenshots is kind of like including the proof that your CSS change worked and didn't have any of that collateral damage. as a reviewer, it's really helpful to see that screenshot right there in the diff. So I can even show you what this UI looks like in GitHub. So they have a lot of the same modes as webdiff does. So they have a swipe mode where you can swipe back and forth between the before and after. They have this onion skin mode where you can, go. Well, it's hard to find the swipe, but you can definitely get a sense of what's going on in the diff from GitHub on the code review screen. And also, if you prefer to get a larger version of the image or see the perceptual diff, you can also pass the pull request URL into webdiff, and it'll pull down the files and diff them for you. All right, so lastly, we have some issues with screenshot testing and some advice about how to incorporate it into your project. So here's another perceptual diff. Here's another before-after. The top is the before, the bottom's the after. Can anyone spot the difference here? I'm guessing you can't. The links are subtly different shades of blue. So eventually, the issue is that the top one was generated on my coworker's machine, the bottom one was generated on my machine, and I think I was running a slightly different point release of macOS 10 than my coworker was. So there are some normalization problems, right? Like you either need to make sure you're all running the exact same versions of your operating system and Phantom.js, or another option is you can use some server to generate the screenshots for you. Dpxdt can do this. Also, Sauce Labs, if you want to use Selenium, you can upload your you can use Sauce Labs to take screenshots in a known configuration in a real browser. I haven't personally tried that myself. I saw that Sauce Labs has a booth though, so I'm definitely going to go talk to them later. So screenshot tests are great, but maybe you don't want to incorporate them into your repo in this way where you update them on every single commit. So one other way you can use them is just for QA on your releases. So I've shown a couple of screenshots of this charting library. So the way that I've always done tests for this is I have a directory of small HTML files that each render a graph in a slightly different way. So you can imagine where this is going. So to test this, when I did a release, I just created a dpxdt setup, and it spins up a simple HTTP server, switches over to the other repository, and then loads all of these URLs and takes screenshots. So it's a really easy way to check what's changed from release to release. So I'll just show you some examples of that here. So some of these should be familiar. I use this to generate a lot of the examples at the start of the talk. So here you can see some of the x-axis labels changing. This is a place where showing the perceptual diff really helps a lot. There are a lot of charts on this page, and this gives you quite a bit of confidence that only the labels are changing. There was nothing else on this page that changed that is escaping your attention. And finally, I'll show you an example of a real bug that was caught by this. So let me turn off the perceptual diff so you can see what's going on. So these are charts that are just drawn in a variety of configurations. The red outline is the before, the green outline is the after. You can see that some of the x-axis labels were dropped. That was intentional. But if you look at the bottom right, you can see that all of the lines moved by about a pixel, and there was something weird going on with the shading in this chart. So that turned out to be a real behavior change during a release of this library that I had no idea about, and I never would have known about without screenshot testing. So of all of those dozens of test pages, there was one real behavior test, and screenshot tests made it a lot easier to find that. All right, so when should you write a perceptual diff test? So one rule of thumb that I like to use for unit tests to try to convince new engineers that writing unit tests isn't so bad is if you ever find yourself iterating on code in the Python shell, reloading making changes to your function, reloading the module, then calling a function again, reload, call the function again, you should probably stop and convert whatever you're doing to a unit test, because that is a perfect example of something that should be a unit test. And I think kind of a similar idea is true for screenshot tests. If you find yourself reloading your browser over and over again as you make CSS changes or backend changes, or you find yourself constantly resizing your browser to different widths and heights to check if anything breaks, that's a pretty good sign that you should be writing a screenshot test instead. So in conclusion, screenshot tests are a good way to track visual changes to web pages. The visual diff tools can help you spot even the smallest of changes, and there are a whole lot of good reasons to add these to your source control. So hopefully you guys learned a lot about screenshot tests today and are interested in trying them in your own project. Thank you.
All right, folks, we have a few minutes for questions. We have microphones here and here. I will start with one, though. Dan, everything that you were showing today, there was no sort of authentication or post request or anything like that. Can Depicted handle that, or is it something where it's only going to be GET requests? Yeah, so this has to be a test version of your server. So whatever you use for bringing up your server in a test configuration, if you have some way of mocking out your authorization system, you'll probably want to use that for your Depicted test as well.
Kind of a similar question with regards to elements on your page that render in JavaScript, like hovers, where you're testing to see how the hover changed. How do you script that in Depicted to trigger that case? Yeah, so in Depicted, you can inject JavaScript into the page that can force an element to be in a particular state, like a hover state, for example. If you're using Selenium or with WebDriver, you can even tell the browser to pretend that the cursor is at a particular pixel coordinate. So you can test those things. Pages that are generated dynamically via JavaScript are a little bit of a challenge. You usually need to add some sort of logic to wait for the page to be available. So often what you do is say, like, wait for a particular element, an element with a particular ID to appear on the page before you take the screenshot. Thank you.
Hi, I'm curious as to what browser or rendering system is used by default by Depicted, and if you can set it to test across different browsers.
Yeah, so Depicted only uses Phantom.js, which is based on WebKit. So that's what you're going to get if you use Depicted. Some of the other tools that I mentioned, though, use Selenium, which gives you a choice of whichever browsers you want to use. You can use Phantom via Selenium as well. So if it's important to you to test across a variety of browsers, Selenium is probably the way to go.
Thank you.
I was wondering, so it seems there's not the capacity for like user interface interaction in Depicted as there is in, like you said, Selenium. But at the same time, I don't think Selenium has the same awesome like image comparison that this does. Do you know of any other happy mediums than Sikuli? Because Sikuli is the only one I can identify.
Yeah, so I guess my hope is that if you separate the image diffing from the screenshot generation, then you can kind of get the happy medium that you're looking for. Like if you use Selenium to just write out screenshot files, then you can use whatever diff tool you want to look at the diffs between the images. I think that's an advantage of putting them in source control. That's another important difference between the Depicted test workflow that I showed you guys initially, and then the workflow where we just updated the screenshots and looked at them with the diff tool, is you kind of separate those two concerns.
Okay, and I guess the other half of that question would be, does Depicted support like a tolerance? So I know that Sikuli uses an image matching algorithm, and so you can allow it to match like a certain amount of deviance, but not too much, and you can change that. Is there a similar? Yeah,
I don't know the answer to that offhand. It does show that distortion number. So if it doesn't, it would be a simple thing to add.
True.
You do have to be careful about that though, because if you have a large screenshot and like some small part of it changes, it's really hard to say a priori whether that change is okay or not, right? Like if you have a year that changes from 2010 to 2018. Like that's only a few pixels difference, but actually that's kind of a problem. So you do have to be really careful to about setting thresholds like that.
Makes sense. Thank you.
Yeah, I'm curious how you use this. You say you commit all of your screenshots. Do you do that every commit? Do you take a screenshot of every single page in your app? And then are you using that for any kind of continuous integration scenario?
Yeah, so I usually update the screenshots when I send out a pull request. Kind of my one dream I have is to actually have Travis generate the screenshots for me and make sure that they're up to date, because that's something that's done manually right now in my group, and it's very easy to forget to do it. But there are definitely people who use screenshot testing for continuous deployment. So Brett, the person who I mentioned at the start of the talk with the pony, they use dpicted for continuous deployment. It can also run in a server mode, and I believe they use it to check whether the screenshots have changed, and if they haven't, or if the changes are expected, they immediately deploy. So there are ways of doing this that involve the full deployment process too.
Where would I go to look for
You
documentation?
should look up the dpicted repo on GitHub.
All right, thank you.
Last call. Any more questions? All right, we got one more.
I was just wondering, do you have any tips for, let's say I have a site and it has a sliding picture thing, then depending on when you take the picture, it might, it might take a picture of a different thing.
Dancing pony, maybe.
Yeah, sure.
So I think animations are definitely a challenging thing. You do need to get your page into a known stable state. Otherwise, you can have flaky screenshot tests just like you have flaky unit tests. So you either need to have some way of setting your animation to pause at a particular moment or stop at a particular moment. It's not an easy thing, but if you want to use screenshots, that's what you need to do.
All right. Thank you, everyone, for coming out. Thank you, Dan.
Thank you.